Hey guys, this is Mr. Grice for Algebra 2, Chapter 3.7, 3.9 review, video number 2. Sorry that I was so rudely interrupted in the middle of number 7. So we're going to start right there. The directions say to solve the inequality and to write the solution set in interval notation. Then graph the solution. So what I started to talk about was how we need to use SADMAP when we are solving these equations, okay? So I'm going to draw the line down the middle of the inequality, and I'm going to get started. So to get the x by itself, the first thing we have to do is get rid of that positive 4. So I'm going to use the inverse or the opposite operation. So we're going to subtract. And we get negative 5x is greater than or equal to 20. Now, the x is not by itself yet. We need to get it by itself. So we are multiplying by negative. So the inverse of multiplication is division. Now, what did I just divide by? Yeah, I just divided by a negative. And whenever we divide by a negative, we have to flip the sign. Okay? If you don't know that yet, or if you forgot, the rule is if you multiply or divide by a negative number, you flip the sign. If you don't remember that, maybe you should get it tattooed on your forehead or something. Okay, maybe your wrist. You'll see it better there. Okay, so now we have 20 divided by negative 5, and 20 divided by negative 5 is a negative 4. Okay, so over here, we're graphing x is less than or equal to negative 4. Well, that means that we're closed at negative 4 and it's less than, so I shade everything to the left. And just make sure that you draw an arrow there. So interval notation, where does the graph start? Well, it starts all the way to the left, which is, yeah, that's negative infinity. So negative infinity, we use parentheses, and then our graph stops at negative 4. And exactly negative 4. It can equal negative 4. That's why we have a bracket. All right, next one. So once again, I'm going to draw the line down the inequality. And for this one, we have to distribute, okay? We have to distribute that positive 3. Well, the negative 8 comes down, and I have 3 times x, which is 3x, and 3 times 2, which is 6. Okay, now on the left side, we have to combine like terms. I don't want to see people subtracting 6 like that. That is not what you are doing. You are doing negative 8 plus 6. Negative 8 plus 6 is negative 2. Okay, now I have x's on both sides, okay? We don't want variables on both sides. I want variables on the left side. So I'm subtracting the negative 4 to the other side. Yes, we will have a negative variable right now. That's fine. Okay, so now we're at SADMAP where we add 2 to both sides. I have negative 1x is less than 0. And the last thing that we have to do is divide. And what am I dividing by? That's right, I'm dividing by a negative, so I've got to make sure that I flip that sign. So it's going to be greater, and 0 divided by negative 1 is 0. So over here we are graphing x is greater than 0. At 0, the graph is open and it's greater than, so we shade everything to the right. Okay? So when we're writing interval notation, my graph starts at 0. with a parentheses, and then it goes to positive infinity. Okay. Number 9. The first thing that I notice about number 9 is we've got two things to distribute. 3 times 3 is 9x. 3 times 8 is 24. Minus 7 is greater than. Then over here, we're distributing the 2. 2 times 7 is 14. And 2 times 1 is 2. Okay. And once again, we have to combine our like terms on both sides. So on the left, we have 9x. 24 minus 7 is a positive 17. 14x, and then 2 minus 5 is negative 3. Okay, so from here I want to get the variable to one side. I'm going to move it to the left. So I'm going to subtract 14x to both sides. 9 minus 14 is a negative 5x, plus 17 is greater than negative 3. And we're going to pause it right now, and you guys are going to solve and graph all on your own. Pause the video. Good luck. Okay, so you should have subtracted 17 to both sides. Divided by negative 5, I divided by negative, so I flip my sign. And then I get that x is less than, oh, not negative 4, 4. I had it right on the right side. Okay, so there's my graph. And then writing it in interval notation, we start at negative infinity, and then it goes to positive 4. Okay, let's flip it over. All right, number 10. Now, when we have the OR graphs like this, sorry guys, it's being a little weird. I have two separate problems, okay? We'll just call it my yellow problem and my blue problem. And I'm just gonna separate these because I don't really care about them until the very end, okay? So let's start with the yellow. Let's solve. I'll just subtract 1 for both sides. And we get 5x is greater than or equal to negative 5. To get the x by itself, I divide by 5. I am not dividing by a negative, so I do not flip anything. And we get that negative 5 divided by 5 is negative 1. Okay, now on the right side, our blue side, we're going to do the same thing. We're just going to solve for x. We're going to subtract 1 to both sides. And we get negative 3x is greater than or equal to 9. And to get the x by itself, I have to divide by a, that's right, a negative. And when we divide by negative, we have to flip the sign. So the x is by itself, and then we get negative 3. Yep, I didn't flip the sign. There we go. Okay, so when I'm getting ready to do my big answer right here, I want these in order, okay? So they're in order from least to greatest. So we would put x is less than or equal to negative 3, or x is greater than or equal to negative 1. So let's take a look at what that graph would be. I'm just going to rewrite it right here. X is greater than or less than or equal to negative 3, or x is greater than or equal to negative 1, just so we don't forget. Okay, so we'll do the blue first. At negative 3, we're closed, and we shade everything to the left because it's less than. Here we'll do pink. Once again, I'm closed at negative 1, and I shade everything to the right. Okay. Now, doing the interval notation, our graph starts at negative infinity, and goes to -3, where there's a bracket, we would say there's a union. And then our graph picks back up at -1 and goes to positive infinity. All right, number 11. Why don't you see if you guys can do the solving all on your own, okay? We have, once again, we have 2 problems. And then we're going to put everything together down here. Okay, so pause the video and good luck. Okay, so you should have gotten x is greater than -2 or x is less than or equal to 5. Okay, so I'm just going to come over here and I'm going to graph it. I'm just going to rewrite what I'm graphing so I remember. X is greater than -2 or x is less than or equal to 5. Did I get that right? Good. Okay, so at -2, I'm open and I'm going to shade everything to the right. And then at 5, I'm closed, but then I shade everything to the left. So as we go through that, we end up seeing that the entire graph is shaded. So as we're writing that in interval notation, it starts at -infinity, and then the graph goes to positive infinity. All right, number 12. Okay, we've got the 2 problems again. On the left side, to solve for x, we have to subtract the 8 to both sides. And don't forget about that negative. Negative x is less than 1. Now to get the x by itself, I have to divide by a -1. And then we get x is greater than -1. Well, why did I change the sign? That's right, because I divided by a negative. All right, on the right side, x isn't by itself, it's being multiplied by 1/10. And to get rid of that, I need to multiply by the reciprocal. Okay, I did not multiply by a negative, so I am not changing my sign. Now, what we have to do here is 2/5 times 10/1. Okay, now if we multiply straight across, we get 20 divided by 5, and 20 divided by 5 is 4. Okay, so we have x is greater than -1, or x is greater than 4. Let's go over here and graph that. So x is greater than -1, or x is greater than 4. We'll start with the blue. At -1, we're open, and I shade everything to the right. At 4, I'm open, that's shaded in, and I shade everything to the right. So here's one of our special cases. Now when I write this in set notation, or interval notation, I'm sorry, I'm open at -1, which means parentheses, and then that graph goes on to positive infinity. Okay, 3 more to go. Now, for problems like 13, remember, we want to get the x by itself. So I'm going to draw a line down the middle of both inequalities. And now all we're going to do is follow the rules of SADMAP. Okay? So we're going to subtract 3, and I'm going to subtract 3 to all 3 sides. -7 minus 3 is -10 is less than 2x, which is less than or equal to 13 minus 3 is 10. Now is the x by itself? Nope. We have to divide everything by 2. And then we get -5 is less than x, which is less than or equal to 5. Okay. I'm just going to rewrite this over here. -5 is less than x, which is less than or equal to 5. So at -5, I am open, and at +5, I'm closed. When our inequalities are set up like this is called an AND graph. So we shade everything in the middle. And if you have difficulty with that, if we look at this, our first one is saying x is greater than -5. It's pointing at the -5. And then in the pink, we have x is less than or equal to 5. And those are the only thing that it wants, okay? So as I write this in interval notation, our graph starts at -5. I'm open, so I have parentheses. And then at +5, I'm closed. So that's why we use the bracket. All right, number 14, we're going to pause the video and we're going to see if you can solve this one all on your own. Good luck. Okay, did you get 4 greater than or equal to x greater than or equal to 1? Well, remember, when you divide by a negative, you have to flip the signs. Now, the only thing that's wrong with this is we need to rewrite it because we want it in proper order, which is least to greatest. So I'm just moving the numbers. X is still in the middle, the 1 comes up front, and the 4 goes to the end. Now, as I'm looking at these two, the x is greater than or equal to 1, the inequality is pointing at the 1, so I need to make sure it's still pointing at the 1. Same thing with the 4. The inequality is pointing at the x, so I'm going to make sure it is still pointing at the x. So when we come over to graph this, this is 1 less than or equal to x, which is less than or equal to 4. So I'm closed at 1, I'm closed at 4, and with this type of graph, we shade the middle. Putting it in interval notation, I am closed at 1, and I am closed at 4, and only the middle is shaded. Okay. Last one. Let's go ahead and solve this. I want to add 3 to all sides. -3 plus 3 is 0, less than 3/4 x, which is less than or equal to 3. Now, to get the variable by itself, I have to multiply by the reciprocal, and I have to make sure to do that to all sides. Left is easy. 4/3 times 0 is just going to be 0, which is less than x, which is less than or equal to. 3 times 4 is 12. 12 divided by 3 is 4. Now, I want you guys to go ahead and graph that. So go ahead and pause the video, and good luck. Okay, you should have gotten that it was open at 0, closed at 4. We shade the middle, and then interval notation, we have open at 0, closed at 4. Okay, guys, well, that's it for Algebra 2, Chapter 3.7, 3.9 review. If you have any questions, please come see Ms. Carranza or myself, because we would love to help you out. Otherwise, this is Mr. Grice signing off. Thanks for watching. I would